Today's lesson is on using the discriminant to determine how many solutions a quadratic will have. Before I explain what that exactly means, we're going to quickly look at three different quadratic equations and what their solutions are using the quadratic formula. If you look at this first example, negative 2x squared plus 5x plus 1 equals 0, when you use the quadratic formula, you get these two solutions. And remember, those two solutions represent where the graph will cross the x-axis at two different spots. When we look at the second quadratic, x squared plus 8x plus 16 equals 0, when we go to solve it, we get a 0 underneath the square root. So when we split up our equation, we end up getting the same answer twice because when you add 0 and when you subtract 0, you're not actually changing anything. So in this case, we get the same thing, which really means there's only one solution. And as you can see, our parabola only touches the x-axis one time, which means its vertex is touching the x-axis, and that is the only point where it crosses the x-axis. So we only have one solution in this case. On this last example, when you go to solve using the quadratic formula, we end up getting a negative number underneath the square root. And we can't take the square root of a negative number, so in this case, there is no solution. And if you look at the graph, it makes sense because our parabola never crosses the x-axis, so there is no solution. Now, you do not have to go through the full quadratic formula to determine if your quadratic will have two solutions, one solution, or no solution. You simply are just looking at what number do you get underneath that square root. If you get a positive number, it means that you're going to have two different solutions. If you get 0, adding and subtracting 0 doesn't create two different solutions, so we just have one. And if you get a negative number underneath the square root, it means that you have no solution. So we don't really care about the whole formula, we simply just want to look at the numbers that go underneath the square root to determine how many solutions there are. Because in this lesson, we're not actually finding our solutions, you're just determining the number of them that you have. Here we have the quadratic formula, and then over here we have the discriminant. The discriminant is just taking part of the formula and using that to determine how many solutions. So here's a chart that basically describes the whole lesson. We are just using the discriminant to determine how many solutions. If the discriminant, if you evaluate that and you get a number that is greater than 0, that means you'll have a positive number underneath the square root. So you'll have two solutions and your graph will cross the x-axis twice. If your discriminant is exactly 0, so you have a 0 underneath the square root, it means that you will only have one solution, which really means your vertex is the only point touching the x-axis. And then finally, if your discriminant is less than 0, if it's negative, you can't take the square root of a negative number, so your answer, you would have no solution. And that makes sense because that would be a parabola that never crosses the x-axis. Well, this seems pretty easy. I think I'm going to get this done so fast, I'm going to have time to go to the beach. Let's quickly evaluate the discriminant for these three quadratics to determine how many solutions they will have. For the first one, a equals 1, b equals negative 6, and c equals 9. When you're substituting your values into the discriminant, I suggest using parentheses so you make less mistakes. So negative 6 squared minus 4 times 1 times 9. So negative 6 squared is 36, 4 times 1 times 9 is 36, and 36 minus 36 is 0. So because the discriminant equals 0, that tells you that there is one solution to that quadratic. For the second one, a equals 1, b equals 2, c equals 9. So you plug that in, 2 squared minus 4 times 1 times 9. 2 squared is 4, minus 4 times 9 is 36. So in this case, you get a negative 32. And if you get a negative number for your discriminant, it means that there is no solution to that quadratic. For this last one, a equals 1, b equals 1, and there is no value of c, so we're going to plug in 0 for c. 1 squared is 1, minus 4 times 1 is 0, and 1 minus 0 is 1. Since 1 is a positive number, we get a positive number for our discriminant, which means this quadratic, if you were to solve it, would have two different solutions. So now that you fully understand the discriminant, we're going to do one more problem, and it will be a story problem. Have you ever tried to impress someone with your strength at a carnival? You know, the game in which you have to hit a lever as hard as you can. It propels the ball into the air, trying to ring the bell at the top. Suppose with your force, the height of the ball is modeled by the equation h equals negative 16t squared plus 35t, where h is the height of the ball and t is the time in seconds. If the bell is 20 feet above the ground, will it be hit by the ball? So the question is, with this equation, is it possible to hit the ball so it goes 20 feet high? So we're wondering, if you plug in 20 feet for h, is it possible? Is there a possible solution for t? So we're going to plug in 20 for h and use the discriminant to determine if there is a solution. If there's a solution, that means it's possible that your ball will hit 20 feet high and ring the bell. If there's a no solution, then your ball with this force will not be able to go 20 feet high and not hit the bell. But first, before I can use the discriminant, I have to make sure it's set equal to 0, just like when we use the quadratic formula. So I had to subtract 20 to the other side, and now here's my discriminant, b squared minus 4ac. And I plug in 35 for b, 4 is part of the discriminant, I plug in negative 16 for a, and negative 20 for c. So now I just have to evaluate this. 35 squared is 1225, and then 4 times negative 16 times negative 20 is 1280. And when I subtract those, I get negative 55. So because I got a negative number for my discriminant, that means there's no possible solution to this quadratic. So with this force, there's no way that the ball is going to go 20 feet high and will not hit the bell. Now here's the graph of the parabola from the original quadratic. And as you can see, with your force, the maximum height looks like it was right about 19 feet. So you're 1 foot below the height of the bell. So will it be hit by the ball? The answer in this case is no. There is no possible solution with your force. So there's the full lesson on the discriminant. Good luck with your work.